All right, let's get started. This is the pre-AP chemistry open house. It's kind of like the chemistry AAC in the school district. Okay, all right. First of all, briefly introduce of this course. So that's the class time will be 4 p.m. to 6 p.m. Every Saturday. The first class is going to be on September 9, and the last class will be December 2nd, okay? And there's no class in Thanksgiving, okay? November 25, okay? So this course, we recommend for grade 8 to 11. But if you're in 7 or in 6, so there's actually not a big problem, okay? I'm going to teach this course, briefly introduction of myself. I graduated from University of Kansas, and I have a PhD degree in chemical engineering and a master degree in mathematics, and I also have a master degree in chemistry. I have taught the geometry at Clements High School, okay? And before that, I actually worked in the industry, okay? I actually work in the industry. That's pretty much of my background. Okay, so and I actually taught the pre-AP chemistry for Moment of Learning last year. Okay, it was great experience. So I have wonderful students, and we have very nice, okay, very nice the teacher and the students interaction, and that's what that's what I look at. Okay, so it was a very pleasant experience. Okay, if you have any questions, feel free to type in the chat. Okay, and I can see. So we try to address any questions in a timely manner. All right. A little bit how to enroll this class, how to register this class. Okay, so this actually so you go to Google and you type Momentum Learning. The Momentum Learning website will pop up. Okay, will pop up the so that's office hours. Okay, so that's very important. Okay, it's very important. So you can whenever you go to the Momentum Learning website, that it will pop out first. And you are going to go to 2023 fall. Okay, you go this tab and you go online. All right, online, and the right hand, you can see there's contest math, AMC 1012 school math, coding, AI, and you go to here, biology, US biochemistry, physics, like that. Okay, and then you go into here, and that will show you all the that will show you. Okay, and then you will see the chemistry is here. Okay, so and you can register. You can register here. Okay, all right. Let's go back to the so now I go back to PowerPoint. Do you see the PowerPoint? Okay, right now? That's how to register, okay? That's how to register. So this chemistry is the curriculum design. It's pretty much similar to the Texas chemistry AAC curriculum design. Depending on the students' understanding, I probably give a little bit more stuff to learn. Okay, so the school chemistry AAC is actually pretty easy, and there are less units. So, and because in the students sitting in this classroom actually are kind of advanced than the other than the average school students. So I probably most I give more stuff, okay, and a little bit deeper. Okay, a little bit deeper. For this one, we are going to learn we're going to start with atoms and molecules, understanding this stuff, and then we'll go to what's the reactions, the type of the reactions. Okay, and right, and how the energy is involved in the transfer of the electrons, like that. Okay, so this we'll give a little bit more stuff than the school teach. Okay, so we recommend, as I said at the very beginning, we recommend the students currently enrolled in 7th to 11th grade. But if you're 6th or 7th grade, so you're still good. Okay, you're still good. We're holding no lab, only online class. Okay. And to do the class, you will need a laptop and or a tablet, okay, or iPad, and ask the students to take notes in class, or we'll do the class practice. So you will need a pencil or a pen and a notebook, okay? So this is the textbook we recommend. But you don't have to buy it, okay? So you don't really need to invest any money in the textbook, okay? So I'll have very detailed slides, okay? I have very detailed slides. So basically, you just need the slides and the class recording, and you can do the homework and the quiz or the test, okay? So no need to buy this textbook, okay? All right. But if you happen to have one, that would be great. Okay, if you happen to have one, that would be great. So the slides will be super detailed. Okay. Any questions so far? Okay. So this will be the stuff we are going to teach that the chapter. So we're going to start with the introduction, okay, and what the chemistry really do, okay. The chemistry really changed the world, but how the chemistry works, okay, what the chemistry, this science subject, what the topics this subject covers, okay, and we'll talk about that's very easy, and then we'll talk about the matters and the change, okay. You will see the so and then we'll do the scientific measurement. If you already take the physics, so you're going to use this scientific measurement as well, okay. And we'll do the atom structures, okay. So here is a little bit abstract because we couldn't see the atoms, okay. So and we'll slow down a little bit, okay. That's I believe that this has been taught a little bit in middle school, okay. But middle school, they're just teach a very surface, all right. So we're going to dive in a little bit and to learn more deeper, okay, of the atom, okay, how the structure of the atom, and that's the basic reason why the different elements or the different stuff, they have the different properties, okay. All their different property actually is because of they have the different atom structures, okay. All right. And we're going to and this electrons, okay. So you're going to learn in this course that why this reaction happens. That's all because the electrons actually transfer between this atom to that atom, okay. And that form, and that's the electrons regroup, and that form the new elements and form the new compounds, okay. All right. And this periodical table, that's a very interesting topic, okay, periodic table. So I believe you already learned some, and but we're going to, as we said, we are going to dive in. That's a very interesting stuff, okay. You're going to love it, okay. So you'll see that actually they have pattern, all right. So why this atom, they have this kind of property, and that atom has that property because of they have pattern, all right. So that's depending on their electron structure, all right. So you'll see their electron structure, they have really nice pattern, and the scientists, I mean, several hundred years ago, they discovered that, okay. That's I have to say that that's a huge contribution to the to the human being, to the society, okay. And we're going to learn, and once we have this knowledge, this micron structure knowledge, then we're going to learn the ions and the molecules, okay. And we're going to learn this how they grouping together, okay, how they are the group, and once again because of their electrons structure. Okay, once again because of their electron structure, and we're going to learn the covalent bondings, and then we're going to learn the chemical reactions. Okay, then those chemical reactions. Once you first touch it, you will say, "Oh, that's amazing, right? That's amazing. Why they react and they form this compound A and reacts with compound B, and they form the compound C." Okay, so that's really that you can see the new stuff is created. Okay, is generated. Stoichiometry. We probably will spend a little bit more time on stoichiometry. Okay, stoichiometry is what called the stoichiometry. That's really sounds the new name, right? But it's actually it's just that's just like water. Okay, so you use hydrogen and water. So you always use 2 moles of hydrogen reacts with 1 mole of the oxygen. Okay, so that's so this element or this element, they react by a fixed ratio. Okay, so that's the stoichiometry. Or this compound, that compound. So their molecules, okay, their molecules will be balanced. Okay, will be balanced. So that's a stoichiometry. But the students, they are some they are because this going to involve a little bit math. So and some students they're a little bit confused here. Okay, so we're going to spend a little more time on stoichiometry. And the state of matters. So see, it's just refers to all the, so you have your cell phone, that's a solid, right? And you drink water, that's liquid, okay? And you're breathing air, the air is a gas, right? So that's the 3 states. So we're going to learn the property of these 3 states and how they change from this state to the other. Okay, all right. Okay. Um, and then we're going to learn the behavior of gases. All right. So here we only learn a little bit, very shallow. Okay, very surface stuff. This if you are going to learn the chemical engineering in the future, so you're going to learn far more complicated. Okay, the equations. But right now we only learn a very ideal. Okay, very ideal ideal gases. Their formulas. Okay. And then we're going to learn water. Okay, what's aqueous system? All right, this way I actually touch every single day, right? You put the salt in your food, or you put the sugar in your coffee. That's a kind of aqueous system. Okay, so and solutions. Okay, that's pretty much like this. Okay, so you're going to learn what's the solvent. Okay, and so let's say this. Yeah, you put more sugar, you feel more sweeter, right? So and you will learn concentration and what's the properties of about the solutions. Okay, like this. And the thermodynamic thermochemistry, we learn a little bit. Okay, this part we learn a bit because it's kind of a very abstract. Okay, what's the enthalpy? Okay, what's that? So that you cannot see that. You cannot. It's this actually is more abstract than the solution or water. So you can touch the water, right? You can see water, drink water, and you can see the solutions. And for the chemical reactions, so you can the reactions you can observe the change. Okay, so you can see when that reaction happens, you either can see the color change, or you can see that the gas was created, right? Or so kind of you can feel the heat was generated like that, okay? But this kind of a thermodynamics is they are very abstract concepts, all right? So we only touch a little bit, okay? And the reaction rates and the equilibrium. So if we have time, so we are going to touch it. But once again, this is a very complex subject, okay? Because the reactions are very complicated. So we only touch a little bit. And this acid base, this sauce, we're going to talk a bit more details, right? So acid, just vinegars. You taste you probably use vinegars in your food every single day, right? So and the lemon juice, white sour, and so you have baking soda. When you taste it, that's pretty bitter. That's a base, okay? And the salt you use every single day, okay? And how they react with each other, okay? Acid plus base would react and they form the salt and water, okay? How does happen, okay? And how do we use this kind of reactions, okay? And we're going to talk about detail of this one, all right? And this reaction, the next one, the oxidation and reduction reactions, we're going to talk about details, all right? So majority of the reactions, as long as they involve the electrons transfer, so they can be viewed as oxidation and the reduction, okay, reduction reactions, okay. That's a very, very important one, okay. I have to say that for the pre-AP chemistry, radon, okay, we call them radon reactions and acid bases. They are actually the most important reactions we're going to learn in this course, okay? All right. And then we'll learn some electrochemistry, okay? That's we'll touch some, but not very, very deep, okay? And this we'll just learn. So hydrocarbon is organic chemistry. So organic chemistry will only, let's say this, organic chemistry is the biggest branch of the in the chemistry, this subject, okay? So you'll see that's, I have to say, about 90% of the reactions or the products that we produce every single day is organic chemistry. They're using organic chemistry. So we use this acid and base. This kind of we call it this kind of is this reaction is the inorganic. Okay, this inorganic. Inorganic is like a fertilizer. That's the inorganic. Okay, so they are important, but they are much less than the organic chemistry. I mean, in the whole industry. Okay, in the whole chemical industry. Okay. But because this is super complicated, this subject, okay, I have to admit that I never did perfect in the organic chemistry course, okay. So but in this one we will only teach a little bit, okay. We only teach because and for the organic chemistries, and they will branch. There is another branch called the polymers. Okay, so that's because it's so complicated. So they're actually formed another branch. Okay, so but we'll talk about it. But not only a surface compounds we're going to talk about, and the function groups and chemistry of life were just a brief introduction. Okay, these 3 chapters. Okay, but it's very nice. Okay, it's very nice to have this a little bit knowledge, and you understand this you have the you understand this concept. Okay, so you don't have to know very much. But after this course, you have concept of this, concept of the hydrocarbon compounds. That's very nice. Okay, that's already very nice. Okay, all right, all right. Any questions for me? Okay, if there's no questions, oh, sorry. So if there's no questions, so we're going to have a bit, okay, to touch a little bit chemistry, okay. So first, what's the chemistry, right? So chemistry actually is touch everything about your real life, okay. So right now that this polymer materials, okay, is everywhere. Is so your cell phone, you see that white, the touch screen, okay, the touch screen. So why you can touch it, touch it and it reacts. So that's a touch, that's the material. And what's the all the materials that made your laptop, your cell phone, or your cell phone case, that's a polymer, right? So that's actually the materials. That's the material science, okay, and it's highly related to the chemistry. And as I said, fertilizer, that's inorganic chemistry, okay, and the clothes, okay, so you wear the sneakers, those materials are polymers, right? Okay, and your table, the coating, the paint, they are all chemistry. So that's it's really about everything about your life, of your real life. All right. And even your food, you know that they actually add some chemicals to keep it, especially that canned food. Okay, so they add some preserves, so they and then keep the food more last longer. Okay, all right. So it's really about everything in your real life. Okay, every real life that in everything of a real life, you can see that it's actually have the chemistry involved. All right. So that's the study of the composite of the matters, as we said. So if you divide it further, it will be molecules, and then molecules you divide it, that will be the atoms. Okay, atoms you divide it, you will see nucleus, and you see electrons. All right. So that's all. That's a traditional chemistry subject. That's we talk about. All right. So, but current modern chemistry, even they say that's a nuclear and neutron and proton that can, and even electron. You can further divide that, but that's too far. Okay, that's too far for us. So and we'll learn the what's the matter. Okay, we'll learn what that's so matter. That sounds very straightforward, okay? But we have the definition for matter, right? Matter is anything that has a mass and occupies space, right? So you see, electron actually is a matter because it has mass. So you don't see it; it's very light, but it is a matter, all right? Because it's occupies space and has a mass. And air, okay? So we breathe air every single minute, every single second. This air, that it's we don't feel it, right? But it does has a mass, right? It does has mass, and it's also occupy the space. And how is a gas occupy space? And so because we don't see that, but we're going to talk about that in the class, all right? Alrighty, and materials, right? So what the chemistry do? Chemistry actually they design materials. Okay, they design the materials, and they thousands chemists they study every single day. They invent no they let's say they discover or the new reactions, and these new reactions will create will generate new materials. Okay, that's how they improve the life of the human beings. All right. And all the reactions, all the chemical reacts, they actually involve the energy transfer. Okay, or they involve the energy transfer. So the reactions, they involve the energy. Okay, some chemical reactions, they they produce. Okay, they produce energy. Some they consume energy. Okay, so this the reactions are different. Okay, but they all involve the energy transfer. Okay. And for energy, so what we do for energy that we use for the real life sometimes. So you see the insulation. So you have the insulation bottle, the water bottle. That's actually they study this kind of study how to conserve the energy, right? So for example, you use the insulation materials. Okay, so the hot air, the hot don't transfer into the room. You want to cool air, right, in the room, and the produce energy. Okay, produce energy is that we use it every single day. So when you cook, okay, so that's a natural gas. You burn the natural gas. We don't use the coal right now, but in the past, let's say about let's say 50 or about not 100 years ago. So about 100 years ago. So the coal is the main energy resource. Okay, so by then that the petroleum and is not fully is not widely used, and then after coal is actually petroleum. All right, so and right now the natural gas every single day when you turn on your stove, actually you're burning the natural gas. So that's how you use produce energy. You're burning them. Okay. All right. And the storage energy. We're going to talk about the battery here in this chapter. In this the electrochemistry. The electrochemistry, we totally talk about the battery. And if you go to the school, you pick up you pick up a subject to study. So battery is actually a very good topic. Okay, a very good topic to study. So there are a lot of research on how to improve the battery, improve their capacity, and how long this battery last, and how easy to use. Okay, so so there's a lot of study on batteries. Okay, and this chemistry also plays a huge role in medicine and biotechnology. This I have to say it's a huge industry. Okay, it's a huge industry. So so you just the chemistry they supply the reactions and find there are a lot of work. So you probably see that the main medicine manufacturing or the companies, they applied the patents, thousands patents every single year. Okay, so and then they screen them and see which one is actually is the most efficient, and the cost is reasonable. Okay, because this medicine the reaction is super complicated, and it's so you have to ensure that you have the right structure. Okay, and you have the purity. Okay, purity is very important. So so that's why the method normally is super expensive. All right, so and that's a chemistry's work. Okay, how to make it how to make this medicines work. Okay, can cure the disease, and in the meantime that's the cost is affordable. If it's so expensive, so you still couldn't be used in the market. Okay, all right. Um, so the biotechnology, I don't understand the biotechnology very in a very deep, very deeply. Okay, so because it's not my I work in the specialty chemistry in that field. Okay, so but this is a increasing. Okay, it's increasing and very cutting edge technologies. All right, so that's actually so you probably heard that the people they work in a very big pharmaceutical company. They make a lot of money. So they're not. I mean, they're comparable to those high tech jobs. Okay, so they actually make a lot of money. So when they work in the big pharmaceutical. So other fields, chemistry can be applied to the agriculture. So as I said, fertilizer, that's very important. Okay, so and thanks to the all the development of the chemistry in the agriculture and make the fertilizer and very very efficient. So now we have enough food. Okay, so you probably heard that in the past when the chemistry is not this developed. So they really depends on the weather, right? Yeah, so if the weather is too bad, so they have the risk of starving. Okay, they have, but right now because of the technology agriculture, we'll have less and less this risk of the shortage of the food. Okay, and environmental so like the wastewater treated like this. So there are a lot. Okay, and the air pollution treated. So everything. Okay, so everything you can think of, but that's the main field that we can see that you actually used in our real life chemistry. All right. So the fact, let's talk about the fact I already talked a little bit. Okay, so let's talk about the traditional 5 traditional areas. The organic chemistry already talked about, right? So everything contained the carbon and the hydrogen. So there are living things, the sugar, methane, like this. Okay, they are all called the organic chemistry. So if you see that this compound contains carbon, contains the hydrogen, so it's actually it's an organic compound. Okay, so I think only the thing that you can think of as not organic I have said above 90% compound is actually contain this organic chemistry, this organic compound. All right, so the sugar you taste, the rice, the flour that your mom used to bake the cake, that's all the organic chemistry. Okay, and only thing that CO2 and CO, carbon dioxide, carbon monoxide, they contain carbon, but we treat it as inorganic chemistry. Okay, inorganic compound. All right. So the inorganic chemistry, so generally, so something does not contain carbon, right? So I can say that it's not living, so salt. Okay, the salt that does not contain carbon. So we treat it, we use it every day, and we treat it as inorganic. And water. Okay, water actually only contain hydrogen and oxygen. Inorganic chemistry is actually, it's very important, but we don't have very much of I mean, the whole chemistry industry, organic chemistry it's about above 90%. Okay, inorganic, you have let's say catalysts. Okay, you have catalysts, glasses. Okay, so they're actually inorganic chemistry. They're very useful. Okay, so a lot of reactions, if they don't have the inorganic catalyst, so that the reaction even won't start. Okay, so that's very important. And biochemistry, as I said, that study takes place in the organism, but I don't understand in very deeply. Okay, And analytical chemistry, that's very important. That's super, super important. I have to say that's analytical chemistry. So especially in this pharmaceutical industry and the bio, super, super important. As I said, the purity, okay? The purity is super, super. And the analytical chemistry, their job is just detecting, okay? Detecting what's the composite, okay? Even they trace the very, very, very little about the amount of the impurities. So that's their job, okay? Sometimes they do distinguish why this doesn't work, why this work, this doesn't work. Okay, so they'll have the analytical chemists help them to analyze, okay, what's the trace impurity in their medicines, okay? Not only in the pharmaceutical industry, in every there's organic, inorganic, biochemistry, they all need this analytical. Okay, very, very important. And the physical chemistry, this subject, this area does not deal with the reactions. They don't discover what the new reactions, okay, or the focus of them is not to create the new reactions or the new chemists produce the synthesis, the new chemists, the chemical stuff, right? So the job of them is to study the reaction mechanism, okay, and what's the reaction rate and the energy transfer. Okay, that's called the physical chemistry. Why this is important? Because as you will learn this in the future, right? So everything in the lab is much easier. Okay, you use glasswares and very easy the mass transfer or the energy transfer like that, right? But how do we make it? We can scale this up and produce in the plant. That needs the physical chemistry to understand all the reaction rate and the energy transfer, the mass transfer, and make it can be they'll study this and this really we can scale this up and commercialize. All right, that's a very, very important step, right? So sometimes you can make something in the lab, but it just couldn't be scaled up and be commercialized in the real industry. There's a lot of time that's because of the rate and the some will call the yield, okay, if the yield. So all this will related to the cost, okay? So if you commercialize a product, so it needs to have a very reasonable cost. If the cost is too high, so and nobody and the customer couldn't afford to buy it, so it will fail, right? So that's all very important. Okay. So for current, okay, so the chemistry that we divided into we classify this into this five, but they're not actually very strictly distinct with each other, okay? So they actually connect and cross-link to each other, right? So as I said, so all this is there. They will need the analytical chemistry, and if you try to scale up or commercialize, so you all this stuff, you will need the physical chemistry, okay? All of this. All right. Any questions? Alrighty, if there's no questions, we'll talk about all right. So I understand that you have learned the science in middle school, okay? But to take the chemistry, that's where you start to learn the real scientific method, okay? So the scientific method, that's the way that scientists and chemists they discover something, okay? They discover the new stuff like that, okay? All right. So they started with the observation, all right? So there are a lot of the great stuff discovery. They started with the observation, right? So for example, Newton, okay, they observed the apples fall on the ground, right? So and then you came up then you this observation, you came up with a hypothesis, right? So for example, if you mix the vinegar and the baking soda, and you will see you all made the volcano in your elementary school, right? Why it's popping out like that? And you make the hypothesis, some gas, okay? That's some gas caused the popping up. So, and you make the hypothesis and based on your observation, and then you will do some experiments to verify, okay? To verify, okay? And then if you experiment, okay, it results, okay, can verify your hypothesis, and then you'll come, we call the scientific law, okay? So you see scientific law, when you learn the physics in the future, you'll see Newton first law, Newton second law, kind of like that. Okay, so the scientific law is just a summarize of the results of the so many observations and experiments, okay? All right, so that's called the scientific law, okay? And once you have so many thousands and thousands of experiments, you come out with a scientific law, and then you summarize them to a theory, okay? And once you have theory, and you do the experiments to verify, okay? So that's the whole process of the scientific method. So if you're going to choose this scientific major in the future, so you're going to do this every single day, okay? Observe, come up with a hypothesis, and then to design experiments to verify, come up with a scientific law, and then come up with a theory and do more experiments to verify, okay? So that's the real scientific method, okay? Alrighty. All right, let's see we talk about the matters of states, right? The states of the matter. Without the air, that's a gas, right? So, and what's liquid? Water is a liquid, and solid, the salt, okay? Or as solid, okay. So the gas, okay, I talk about you can see this the pictures. So that's some crystals, right? That's some crystal. Let's say the salt at if you use a microscope, it could look like this, okay? And we call that as crystal. So why the gas? You can see that the air when the breeze when the air flows, you can feel that, right? Why it can flow that easily? So you see that here, okay, it's just a diagram to show you how the molecules of this gas there. You see that the molecules, they are actually far away, right? So that's why they can easily flow, right? And in the liquids and the molecules, they actually get closer, right? And they still can flow, but you can see they're much more denser than this one, right? And that's the salt, okay? That's the crystal. Either you can see this either atoms or the molecules. They actually closed, okay? Closed packed, and that's why they have the definite shape and the volume, okay? And they don't flow like water, and they don't change the shape, okay? So you see that the gas and the liquid, they have no shapes, right? So it really depends on what kind of container. If you use this kind of bottle, that's it. That's it. They don't have shape. So the shape is the container's shape. Okay, you see there's a bigger, right? That's a bottle. So it's kind of like that. All right. So can you think of 3 states of water? So water, the water you see the most is the liquid, right? So can you give me can you think about the solid water, let's say? What kind of a solid water you can give me, for example? Let's have a discussion, right? So think about for, let's say, for 30 seconds. Very nice. Okay, good job. All right, ice, right? Ice actually. So if you put the water in the refrigerator, then you will get ice, right? So it's not liquid. Sorry, it's not solid. It's no longer liquid, but it's still water. Okay, but it's still water. Okay, very nice. What else? Solid water. Oh, let me call back this question because it's Houston. So if you live in Houston for your entire life, so it's not good. So the other one is the snow. Okay, the snow actually is the water. Okay, so it's the water, but it's solid. Okay, so but for Houston, so if you live in Houston, you barely see the snow. Okay, you barely see snow. And let me ask, so what kind of a gas can water be gas in the state of gas? Have you done boiling some water? Let's say so you want to make a tea or coffee, right? So you put it in the kettle or the electric kettle or in the stove. You heat it up, right? So when the energy, so let's say this water, okay? So when these molecules, when you heat it up, it's gain energy, right? So when you gain energy, those molecules were they are moving, okay? They are moving, always moving. They are not sitting here like this, okay? So they are moving always. So and so once it's gained the energy, so that's actually moving faster, all right? They are moving faster and they'll break. That's the attraction of each between these molecules, and then it will escape, okay? It will escape in the air. So, and that forms the gas, and they'll be like this, okay? So even in liquid, okay? So they're actually moving, okay? They're actually moving. So the vapor, okay? So water vapor. So if you hit the water, you see that, right? You see that. Okay. All right. So how the state conversion, how this water becomes the ice, right? And how the water becomes the vapor. So that's really depends on the temperature and the pressure. Okay. So those two variables change. So because you know that you put the water into the fridge, and that's the temperature goes down very low, and then you have the ice, right? So that's the temperature and the pressure change. They'll cause the state change. All right. Okay. Now I'm going to ask you to think about any. This as your homework. Okay. Can you think about the other examples? Okay, except water. Okay. All right. So for the state change. Okay. I think that's the last one. Okay. So that's this diagram actually shows the state of matter change. Okay, the state of matter change. So that's the water. Okay, Fortune, that's the water. So we start from here, right? We start from here. So you put a cup of the water into the fridge. Okay, so it's freezing. Okay, it's losing energy, and then it creates ice. That's ice, right? And we put the ice out, okay, put in the room, take it from the fridge, and then is observe the energy, okay, because the room temperature is higher than the ice, so it will absorb the heat, and then it will melt, right? It comes back to liquid, okay. So when you're boiling the water, so we call this as the evaporation, and then becomes the vapor. That's a gas, right? And so, okay, so from gas to liquid, who has oh, you can see give me an example of the condensation. We call this from gas, vapor, water, gas, vapor, to the liquid. We call the condensation. Anybody can give me an example of the condensation? So what the real life process, you see that you can see the water, they come from the gas, the water gas, and become the water liquid water. Super nice. Okay, very good. Okay, good job, Jane. Yes. So the air conditioners, right? So so the other example is the rain. Okay, so the rain actually you see the clouds on the sky. Okay, so they contain the water vapor, and so why we have the rain? That's because the temperature becomes colder, and then they become and they lose energy. Okay, they release energy, and then they condensed into the water, and we have the raindrops, rainfall. Unfortunately, we haven't had any rainfalls in this. I mean, how many days? I don't know. It's too dry in Houston here, right? So, but next time when it rains, think about this is actually we call the condensation, right? That's a state of change, of matter change. Okay, so the gas to the solid, you don't see this very much. Okay, so it's not common as we have in this. There's you boiling water, you have the rainfall, or you make the ice cube and the ice cube melt. You see this, okay? You see it. But from gas to solid, so from gas to solid, so we call decomposition. Okay, this actually happens sometimes. It doesn't go through the liquid. It's from the water vapor, it deposit into the ice. Okay, directly. And sometimes the solids, they become the gas, okay, without going through the liquid, being liquid. Why is that? That's what we call the sublimation. So this actually, you guys have never experienced this. So in the water, in the very cold area. So if you have your clothes have it even have ice in your clothes is for example, and then it's you don't really uh, this ice or whatever, or let's say snow. If you have snow on your clothes, so sometimes it's not going to liquid. It's just you feel, and after a while that you feel your clothes actually dry. This solid, this snow actually go change back to the water vapor directly. So we call this a sublimation. Okay, so yes, very nice. Okay, good job. All right, I forgot this dry ice. Right, great, good job. Okay, thank you, Jay. So yes, so in the you have I think in your elementary you probably did this experiment as we call the dry ice. Dry ice is not really ice. Okay, dry ice is carbon dioxide. Okay, so and then you have this. It goes to becomes air becomes the gas. Okay, immediately when you release that. So that's a very that's a perfect. Okay, the best I have to say the best example of the sublimation. Okay, all right. So that's all about the, and I did not give any reaction. So when we talk about the reaction, it's even more interesting. Okay. We have only 2 minutes left, so I'm going to show you the office hours and the phone support. Okay, and this also can be found in the when you go to the Momentive Learning website. Okay, as I show you, that it pop out the first time. Okay, whenever you go to the Momentive Learning, this information pop out first. Okay, all right. So any questions? All right, if there's no further questions, and thank you very much for your joining us, and I look forward to seeing you in the class. Okay? Okay, thank you.